Everybody's feeling all right? Oh, I lost Emma. Avery, did you get my email that I need you to resend your assignment?
I got it with the
Yeah.
and I resent it off the printer at the shop. Did not work.
I don't know if it did, Avery. I didn't see it, but we can try that again.
Okay, I'll go to the shop after.
Okay, I'll have a look again. It comes up with something funny, doesn't it? Like
Yeah, like it's the shop scanner.
right. Okay, just maybe send it again today. I just can't seem to find it. Okay. All right. Okay, so basically this morning, how do we make out with 8.1 and 8.2? Do we have questions from 8.1 or 8.2 today? Did you finish 8.2?
Yes.
Emma P, did you finish 8.2 as well? Your mic's on there, Emma. Emma, did you finish it? Okay. Did you have any issues making equations or doing any of that stuff? No? How about are you girls doing well with that Desmos?
Yeah.
All three of you are using it?
Yeah.
Okay.
Yeah.
That's ideal. All right, because that'll be your best friend this year and next year, that program. Okay, well, I'll move on to 8.3. I was going to give you a little bit more time, but if you're done it, I'll move on to 8.3 and I can at least get you started, but I wouldn't worry too much about complete. Well, 8.3 is the last of chapter 8, so we'll take our time and we'll finish chapter 8 this week. We'll do the review Monday. So, okay, so at the end of chapter 4, at the end of chapter 7, we learned about perpendicular lines and parallel lines, right? And parallel lines are lines that have the same slope. Now, why that's going to be important is this section, there are 3 ways in which we can see when we see equations, and the number of solutions that we can have for 3 equations or for 3 graphs. So what I'm essentially trying to say here, as I'm confusing everybody, is there are 3 options for solution numbers. Okay? First option is where I have one solution. And in order for me to have one solution, I just have to have a slope that's different. Okay? So my slope between the 2 lines just has to be different in order for me to have the same solution. So the y-intercepts can be the same. They can also be different, but I have to have a different slope. If I have a different slope, then lines at some point, because they both go left or right, are going to cross at one time. Now, if I have 2 lines that have the same slope and different y-intercepts, that means that I have 2 parallel lines. And how many solutions do I have for 2 equations that are parallel? Answer, 0. Right? Because they're never going to touch, they're never going to cross, which means that they never ever share the same coordinate. All right, they are going to never have the same coordinate that can make their equations equal each other. All right. And the final one that we could have is if the equations have the same slope and the same y-intercept. That means that we have two lines that are identical. And if you have two lines that are identical, that means you have an infinite number of possibilities for this. So there's three scenarios that can happen. The first scenario is where you have one solution. So only one coordinate is shared between the two. The second scenario is if you have no coordinates shared. Parallel lines. Neither one is going to have the same coordinate on them. And then the third one is if you have two exact lines. All right? That way you would have an infinite number of solutions. Okay, so those are the three that occur. So on page 178, they show you them, and then they show you how it works for different slopes, different and y-intercepts. Then it shows you same slope, different y-intercept. And then it shows you same slope, same y-intercept. So those would be the exact same line. Morning, Pedro. All right, so we're on page 179, Pedro. So let's look at an example here. It says 4 students are going to type the same lengthy essay. Shauna begins first. Anna and Christian start together a short time later and type at an equal speed that is faster than Shauna's rate. James begins last and types the same speed as Shauna. If the number of words typed by each student as a function of time could be represented by a linear equation, how many solutions would there be for each system? Okay, so this is kind of weird. It's a different way of asking this question. So what I'm going to do is I'm going to draw out what's happening. Okay, so my independent variable is the time. All right. My rate is going to be words per minute. And actually, I shouldn't put that in here. I'll do this. There's the number of words. And then if this is in minutes, then I can find my rate as words per minute. So it says 4 students are going to type the same lengthy essay. Shauna begins first. Anna and Christian start together a short time later and type at equal speeds. If the number of words typed by each student is a function of time, could be represented in a linear equation. Okay, so Shauna's going to begin first, so this is what it's going to look like. That's her time. Okay, so Anna and Christian start together a short time later and type at an equal speed that is faster than Shauna's rate. Okay, so these two right here, they're going to start a short time later and they're going to type at a faster rate. So that means at some point, so this is, the first one is Shauna, and then this is Anna and Christian. So Anna and Christian, they are type at an equal speed that is faster than Shauna's rate. So they're basically the same person. And then James begins last and types at the same speed as Shauna. So if he starts here and types at the same speed as Shauna, he's going to run parallel to her. So it says this. All right. Between Shauna and Anna, how many intersection points or how many solutions there would be? Well, Shauna's here. She's the black line. Anna and Christian are here. There is going to be one solution between them. So between Shauna and Anna, there is one solution because these two lines are going to cross. Between Anna and Christian, so the two that started together, they're going to have an infinite number of solutions. Okay? So they're going to have an infinite number of solutions because they're the same line. I should have drawn this guy out here. Christian or James is out here. All right? And then it says Shauna and James. So Shauna starts here and goes up, and James starts here and goes up, and they're moving at the same rate. So that means then that they have the same slope, different y-intercepts. Therefore, they're going to have no solution between the two of them because they'll never touch. So they're going to run side by side all the way up and never cross. So there's zero solutions. Okay? Now that's not the easiest of example, but I want to look at, let's go to the practice now. So let's look at the practice questions on page 179, and let's start with question 1. It says, predict the number of solutions for each system of linear equations. Okay, so equation number 1, y equals 4x minus 1, and y equals 4x plus 7. All right, so what do we notice? Well, the first thing that we notice is their slopes are equal. So if their slopes are equal, we're either going to end up with parallel lines or the exact same line. So how do I determine whether it's parallel or the same line? If it's parallel, these two values, the -1 and +7, are going to be different. Okay? They're different. So that means then that I would have, and again, these are terribly sketched graphs, but I would have -1 here, up 4, right 1, so I'd have it looking like this. So this is y equals 4x minus 1. Y equals 4x plus 7 would be up here, and it would run parallel to it. So I go to 0 and 7, up 4, right 1, I'd end up with a parallel line. So in this case, I write no solutions. You can also write an O or a 0 with states that there's no solutions for it. Okay? So because the slopes are the same and the y-intercepts are different, you have no solutions. Let's look at B now. Y equals 3x plus 5. Y equals -3x plus 5. Okay, so what's the first thing that we notice? Well, I notice that my y-intercepts are equal. They're the same. So they both start right here. They both start at 0 and 5. But one of them goes up 3 and right 1. And the other one goes down 3 and right 1. So because the slopes are different and the y-intercepts are different, I end up with one solution. And that solution being 0 and 5. Because they both share the same y-intercept. All right? In C now. Any questions? In C, so our objective then for today is you can either, 1, graph it, then you can see. Number 2 is find the equation slope and y-intercept, and then compare them to find out whether you have one solution, zero solutions, or an infinite number of solutions. So let's look at x plus 2y equals 7. And 5x plus 10y equals 35. All right. Now, from these two equations, because they are in general form, it's not as easy to find out what the slope is. So what I'm going to do then is I'm going to change this to slope-intercept form. So I'm going to go 2y equals negative x add 7. I'm going to divide by 2. I'm going to get negative 1/2 x plus 7 over 2. So my slope is negative 1 over 2, and my y-intercept is 3.5 or 7 over 2. That's for the first equation. The second equation, I'm going to go 10y equals negative 5x plus 35. I'm going to divide by 10, so I get minus 5 over 10x plus 35 over 10. I'm going to reduce my fractions just to see. I get minus 1/2 x plus 7 over 2. So what do I notice about equation number 1 and equation number 2? They're exactly the same equation, which means I have exactly the same line, which means that there is an infinite number of solutions. That means every x and y coordinate that is on this line right here is also on that line right there. And both equations will equal on both sides. A, B, and C are the best way that I can show you or demonstrate to you how this works. All right? By comparing slopes and y-intercepts, we can determine whether or not a line has one solution, no solutions, or an infinite number of solutions. So 8.3, that's what you're spending your time on today, is working through that. Now you can, again, like I said, if you can use the Desmos program, the Desmos app, it makes things a lot faster when you're graphing them. You still need to do some of the algebra just for practice, but you can always check your solutions with the Desmos app. Okay? Any questions this morning about 8.3? You're good? Okay. Okay. Perfect. So I'm going to leave you on, I guess got to step out for a minute, but I'll leave you on line here. You guys can visit. You can talk to each other. I know you don't get to see each other very often. And then if you have questions, you can ask. Okay? So I'm just going to mute myself here. And you can work.